Okay, this is our third lecture, or this will be the third lecture. And before the beginning, let me ask a question to you. Do you know what information retrieval is? Anyone who can define it with a single sentence, maybe? Information retrieval, information storage.
No one that courage enough.
You can give wrong answers too, it's okay. Not every sentence has to be true, but we can guess at least.
Maybe
For
just
me,
to add one now. Maybe gathering information and just systemizing it, putting it all together.
Yes, actually, it can be summarized as being a librarian. Imagine that you work in a library, and there is a problem there, of course, in this analogy too, because first of all, machines don't understand. But to be able to be a proper librarian, you don't need to understand every book, right? When you hold a book, you can check which topic this book is from and what it actually explains and what is it about. And then you can actually choose a section in your library to put that specific book into that place. In fact, in the past, Matt Cutts actually made a couple of good jokes about it, because he made an analogy, and according to the Matt Cutts, a search engine is actually a blind librarian. Because even a librarian, as a human, actually the person understands the books, or he touches it, he examines the images and everything. But when it comes to the search engines, when they have a book, it's not that easy for them to understand actually overall topicality of the book, because they are like blind. They see the words and they see that these words appear together, and there are different distances between these words. There are different chapters and different pages, and if we have certain words on a chapter and another certain word group in another chapter, and we see that actually these specific word sequences and word combinations, they appear also in some other similar books as well. But still there are topicality differences between them. So when you think like a blind librarian, you can assume that information retrieval is actually understanding overall relevance of a document to a phrase. And this phrase doesn't have to be always contextual. For example, you can have stop words in your query, but still, if you are a search engine, you will need to decide which part of the query actually has more weight to understand the overall relevance. Because as a search engine, if you focus on the wrong word or the wrong section of the query, it means that all the results will change, and overall relevance, it might not be good enough. So if we explain the information retrieval in a single sentence, information retrieval is understanding overall relevance of a document to a specific phrase to retrieve it in a search system. And when it comes to the information extraction, it is different from retrieval, but it is a little similar. Any guess now? Again, we can give the wrong answers. I am open to wrong answers. Just give me an answer.
You're asking for the extraction now? Sorry, missed.
Yeah, I am asking for the information extraction. Do you have?
My guess would be that it's extracting the actual relevant information from the information that we have retrieved.
Yes, actually it's correct. So basically information retrieval, we try to calculate the relevance. But when it comes to information extraction, it's not that about relevance. It is actually about taking the information from that specific section, pulling it out, and putting it in front of a user. So when you look at any kinds of feature snippet, it is actually information extraction process. And when it comes to we have actually one more concept here. Maybe we can try to explain it too. And it is information content and information graph. These concepts are also from NLP, by the way. And if we explain the information content, basically information content is any kinds of info or knowledge that we can extract from a document. When it comes to the information graph, it is taking all of the information and putting it into a specific type of graph. And when we say this type of information graph, let me just search, for instance, information graph, let's say NLP. Maybe we can find some images that we can use. Yes, actually, when you look at any kinds of semantic SEO or NLP related thing, actually this is what information graph is. We are extracting certain types of information, then we understand relation types and association of these entities to each other. And yesterday, for example, we have talked about semantic distance. And basically from Eiffel to this person, Lily, or let's say Da Vinci, actually there is an indirect association or indirect relevance. And when you look at the distance, or when you look at the length of this arrow, or when you look at the count of edges and nodes between two different other entities in a graph, it actually represents their indirect connection. If you see more edges and more nodes between two different other nodes in an information graph, it means that they are not that relevant, or they are distant to each other. And of course, there are other ways to bring these things closer to each other as well. And basically, if we repeat all these things, information retrieval is for understanding the relevance. Extraction is for actually pulling out that information and putting it in front of the user. Information content is the content or any kinds of knowledge that we can actually extract from the document. The graph is actually graph form of that specific content. So I will open my Paint right now to be able to explain these things a little further. I will write here a query. If you have any kinds of query suggestions, I can also write them too. Let's say the query love. I'm just giving a random example here. And when I open, let's say these are some of the pages, some of the candidate documents for the query love. Basically, we put them here like this, like this, like this. So there are a couple of problems here. First of all, this is a single word query. And when you have a single word query, the search engine can't understand the query that much, because words that can appear before love and the words that can appear after the love, all of them will actually mean different things. And we will also have different types of entities here, movies, songs, or poems, or we will also have psychological things, or we will also have music bands or events or different things. So the query is not that clear. And when you think like that, the first thing that the search engine actually will need to do is taking the query and rewriting it. And when you rewrite it again, it can be actually love movies, it can be love music, or it can be love, let's say, maybe love as a, let's say, nickname or etc. or other things here. So the thing here is that when you actually start to rewrite the query like this, you will start to distribute certain types of percentages. You can, as a search engine, you can tell that with 25%, this query love is actually equal to the movies. And with 35%, it might be actually about the music. And it might be like, let's say, just 1% can be the nickname. So when you think like that, the information retrieval is actually understanding the most possible relevant document to this query, but not just that query, all of other possible candidate queries that can be rewritten based on this one. And when you look at that, you will start to actually seek all of the possible words that can appear in the documents among these music or these movies or nickname or some other things. And if you see a certain document that just focuses on the nickname, like love as a nickname, for example, it means that overall relevance will be very much lesser. If you write here love nicknames, let's say, like this, and when you look at here, since with only 1% we actually talk about the nicknames, it means that information retrieval score in this one will be really low. Let's say between 1 and 10. The information retrieval score of love nicknames for the query love, it will be just 1. But if we change the angle a little further, if the angle starts to become like love nicknames from movies, Now, since we actually mentioned the word movies together with the love, they will create a different types of combination, and this information retrieval score will actually go to the 6. So why do we need these scoring methodologies? Because when you actually go to the Google and when you search for the word love, you will actually see 14 million, I guess, yeah, more than 14 billions actually, documents. And the search engine, since they can't rank every type of document that just mentions the word love, they will need to create a filtration system here. And when they create this filtration system, it means that under a certain information retrieval score, you will need to eliminate these pages. And it might be like 9.9 because we have 14 billion candidate documents. And it means that if a document that wants to rank for the word love, if they don't touch all of these things at the same time, directly or indirectly, in their information content, their actually information retrieval score will be lower, and most probably they won't be ranked there. So let's dive into the information extraction now a little further. And to be able to explain the information extraction, I will need to draw some lines here. So now our purpose here is actually not understanding the relevance, but actually taking just some direct informations. And when you look at the situation like that, we can't use the queries anymore. Because when you look at the queries do not want information. They actually just simple search queries or simple search terms without any kinds of further information. When you look at the love movies, there is no information need there directly because it is not that clear what you are asking still. For example, are you asking the best love movies, or are you asking the new love movies? Or are you asking the worst love movies, let's say? Or are you asking just the love movie actors? Or are you asking for how to make a love movie, let's say? Or are you asking maybe, let's say, maybe the most interesting love movies? Or maybe you just actually want to learn some certain locations with love movie scenes. Or there are some other things that actually you can search for that. So for further information retrieval, first we have actually rewritten the query with different possible attributes. Now, if we just focus one of them, there will be further rewriting. And these further rewriting will include more specific questions. And these more specific questions, they are not for understanding the relevance mainly. Therefore, actually finding that specific information in these paragraphs. Because even if your document or your website is really relevant, and even if you have the highest information retrieval score for the best love movies, as long as you don't have these specific type of movies in your document, it means that actually you are not responsive to the query. Even if you are relevant, it doesn't mean that you are responsive to the query. Query responsiveness means that you include that specific information in your document. And to be able to understand that, the search engine needs a certain activity, which is called actually named entity recognition. So now we actually don't check certain words, whether they appear in the documents or not. Now we actually need to check whether that specific entity appears in this area or not. And when you look at the situation in this way, beyond relevance, from the point of view to the query responsiveness, you will need certain type of entities in your document, but it won't be good enough too. You will also need to connect all these entities with the right association, with the right relation type. And you will also need to include further information for them. So as you see the queries here, they actually include superlatives like best, like worst, or like most. All these things are actually certain type of superlatives. And when you look at the entity type here, in this case, you will need to create a comparative list to cover all these things. And at the same time, you will need to give their alternatives. You will need to give certain locations or actors or you'll also need to mention their movie set locations and some other things as well. Whatever you put there, as long as you put the most related entities for all these possible things or for all these possible entities, it means that actually you are increasing your possible responsiveness. So I will show you one more concept here, uncertain inference it is called. I will demonstrate it from the Wikipedia, and I will read this section. A user's query can be interpreted as a set of assertions about desired document. It is the system's task to infer, given a particular document, if the query assertions are true, and if they are, the document is retrieved. In many cases, contents of document are not sufficient to assert the queries. By saying content is not good enough, we actually mean that even if you are relevant, we don't know whether you give the right answer or not. And then a knowledge base, it means knowledge graph. A knowledge base of facts and rules is needed. But some of them may be uncertain because there may be a probability associated to using them for inference. And when you look at the concept of uncertain inference, it actually comes from C.J. van Rijsbergen, a Danish as I can know, but according to the statement here actually, he is founder of the Information Retrieval Club in Glasgow University. And when you look at the concept of plausibility, it means that actually the possible reality of that specific declaration or that specific proposition. And when we look at these propositions, you will actually find many documents with different information content, with different information graph. And all of them actually are responsive to the different questions. And while they are responsive to the different questions, they actually include different relations between entities, different attributes, and different orders of the facts along with the different accuracies. So in this context, when you look at the information extraction, it is actually a main section of the semantic SEO. And I will try to demonstrate one more concept here in a simple way. Some of you already know it. It is called knowledge-based trust. And I will open this. Luna Dong actually works for Amazon, but while she was giving this presentation, actually she was working for Google. And when you look at the some of the sections here, so here, basically Luna Dong explains the relation between knowledge-based trust and PageRank. And you already remember the concept of the knowledge base, because as you see here, for uncertain inference, we need to know a knowledge base, a repository of facts. And when we look at the graph here, Luna Dong says that every blue dot that you see on the screen, they represent different websites. One of these dots might be actually NordVPN, the other one might be Kaspersky in this context. And when they create a graph, they realize that certain websites, they have higher page rank. Basically, if you have more links from more quality sources and with more relevance, it means that actually you have more page rank. And knowledge-based trust means that how well your information in the document is accurate and also rich and also easy to grasp, easy to process. And when you look at the screen here, there are some websites on the web with high level of page rank, and there are some other websites with low level of page rank, and there are websites also with low level of page rank, but they have high level of information with high level of accuracy. And when you have accuracy together with the page rank, they call you correlated scores, or let's say actual seed sources, because they can learn a topic from your website, plus entire web actually already approves it. And when you look at this section, there are tail sources. The tail sources, they have low page rank but high level of information. So it means that the page rank doesn't show the quality always. That's why sometimes even if you buy more links, even if people start to link you more, it doesn't mean that actually you will be able to increase your traffic. Or your competitor might have less links, but they might have more queries and more responsiveness and more traffic at the end of the day. To be able to have all of these things together, you will actually need to have both of these things together, and semantic SEO actually focuses on this section mainly. Most of the time we focus on high level of knowledge base trust. And when we look at this section, let me show you how search engine is sensitive. For example, when it comes to the topic cheese, we see that there are different types of triples or different amount of triples, and there are different accuracy levels. For example, for the cheese, the Wikipedia has 1,184 triples. Does anyone know what a triple is?
No.
Okay. So basically a triple is an entity, then a predicate, then we have a kind of object. Let's say subject, predicate, object. Let's say we say a sentence like NordVPN bought X company. NordVPN there, it is actually a subject. The company that has been bought, it is actually the object, and the predicate there, the action that we are doing there, it is actually the predicates itself, or the team, let's say. And when we look at the situation like that, it means the Wikipedia, they have more objects, more predicates, and also more subjects and more triples basically. And the accuracy for these triples, it is actually 76%. And it puts Wikipedia to the top with a score of 5.36. And when you look at the cheesewiki.com, which is another website, their accuracy is higher, but we see that actually their triple count is not that much, and that's why their score is lower. So basically, the triple count and information accuracy, they actually create a score, but as I can see from here, accuracy is the most heaviest actual factor there. Rather than the triple count, accuracy is very much more important. So when you look at this information graph, someone might come and they can actually create an entirely different information graph than you for the same topic. And when you look at the search engine, at the end of the day, they will need to decide which information graph is more accurate, more relevant, more responsive to the questions that we have generated from these queries. So question generation and answer pairing, and making these answers more related and more responsive and more richer, is the basic fundamental of actually semantic SEO. So I can assume that actually we have processed the information retrieval and extraction as much as possible. I will give you one sample from here. Maybe we can look at this document a little later too. So there is a question from Yahoo, and the question says, why are British women so unattractive? And someone here says that Catherine Zeta-Jones is from New Zealand, dummy. So when you look at the web, there is always new information, different information, contradicting information. And one of the questions says that why are British women so unattractive? And someone says that Zeta-Jones is British, and it means that Zeta-Jones is beautiful, and it means that actually this assumption is wrong. And another person says that Zeta-Jones is actually not from the Britain, or she is not a British. And when we look at the knowledge base, actually we see that Catherine Zeta-Jones, actually she is from Britain, but she is not a British, she is a Welsh. So in this case, this specific named entity is not related to this question. And if you are not that careful, it means that your accuracy will be lower. Because when you think in a direct way, you might put a certain entity after a certain entity by giving a specific declaration, and you might assume that it is true. But when you look at the Google's own brain, it might be wrong. And you might end up by giving the wrong information, and it might actually make your rank lower after that point. So with that said, let me continue a little further. I have some basic explanations here. For example, for the query X language, a search engine might find documents that mention the word X, the language, or the X or language, X and language, and some variations like. Speaking of X language, origin of X language, all these variations create different contexts and index samples. And information extraction here, as I say, it is the pulling out the information. And a web search engine can extract an answer to a possible question and match it with the question directly. For example, for the query X language, a search engine can generate questions like how to speak X language, is X language hard for something, and what is the origin etymology of X language. For these generated questions, they can pull out information from documents and that serve them directly, or they can rank documents based on their responsiveness to the query. And when you look at the situation, I will need to explain one more thing. So let's say someone asked for this question. They say how to make a love movie. And let's say this passage, this paragraph, is the most related paragraph to this question. And when someone searches, it means that the search engine actually needs to rank this passage. But just after this passage, here, and here, and here, we have non-quality, completely wrong answers. So as a search engine, would you rank it or would you eliminate it?
Based on knowledge base truth, I believe it would be downgraded in rankings.
Okay, so even if that, I hear myself, sorry. I can, okay, now it's okay. So basically, you're saying that even if this is the best possible answer to give, because of the overall quality of the web page, I wouldn't rank this passage, I would eliminate it, right?
Maybe only for that query, and it could have related queries, and for those you wouldn't be ranked.
Okay. So this is actually what we call as passage indexing. I believe you already know this topic. Google actually already demonstrated what passage indexing is, and I believe you already remember that too. And they say that actually it affects the 10% of the English language search queries. And it is one of the biggest improvements since birth. So first of all, let me explain why it is a big improvement. Because when a search engine changes how they index things, it means it is a new search engine. It is the biggest change that you can do for a search engine. It is the index. A search engine consists of from the index. If you change the structure of the index, it is an entirely new system now. It is a different search engine. And if a search engine starts to index passages rather than the web pages to serve just that specific passage, it means that actually they are changing their overall understanding, and they assume that actually overall relevance or overall quality shouldn't affect certain times for ranking purposes. Because if that document is able to answer that specific question, we should rank it, but we shouldn't rank it for other questions in this case. And it means that even if you have low page rank, even if you have low information retrieval score, even if you have low level of relevance, still just because of the quality and accuracy and uniqueness and added value of this passage, you will be indexed and you will be ranked there. And this is a fundamental change. And according to the Google, they are able to improve 10% of the English queries just by focusing on the passages. And apparently this was a problem of the many years for them. And that's why they wanted to focus on that specific passage. And in this case, even if this answer here says that Zita Jones is a British and she is beautiful, the next answer or the next sentence, if it is quality for another related thing, still the passage actually can rank higher or for a certain amount of time. And when you look at the situation in this way, there is something that we call feature snippet domination. Sometimes, but just sometimes, small amount of time, a passage can rank for a question 100% of time. It is called domination. It happens rarely because even if you most of the time you see the same feature snippet for the same question, actually at least 15% of the time or 20% of the time, search engine actually switches the answers and they continue to collect more data to understand the possible satisfaction of the search, and it might actually can be understood with different ways based on your eye tracking, based on your query session, or there are different types of metrics that they can use, like query per second, or like mouse up, mouse down, or they can actually also check your next query. If you search the same thing with different phrase variations, it means that actually you didn't like the previous answer. And that's why actually the accuracy and comprehensiveness and also groundedness matter there. So I will try to explain one more thing based on the Lambda. As you know, one of the Google engineers, that he claimed that Lambda actually became sentient as a human, like a human, and he is of course fired because he has broken the confidentiality of the Google algorithms. But I can tell that Lambda is one of the most advanced conversational language models. But I am not showing it here just because of that. I will show you one principle from Google for evaluation of their own language model. And it says the current generation of language models often generates statements that seem plausible. As you see, when you see the word plausible, it is same like here, plausibility of an inference. But actually contradicting facts established in known external sources. This motivates our study of groundedness in Lambda. Groundedness is defined as the percentage of responses with claims about external word that can be supported by authoritative external sources as a share of all response containing claims about external word. A related metric, informativeness, is defined as a percentage of response with information about external word that can be supported by known sources as share of the all responses. Therefore, casual responses that do not carry and real-world information affect informativeness but not groundedness. While grounding Lambda-generated responses in known sources does not in itself guarantee factual accuracy, it allows users or external systems to judge the validity of a response based on reliability of its source. So basically, if NordVPN always gives the accurate and relevant information for all these possible questions, all these possible attributes and relations, it means that you are a reliable source for that specific concept and topic now. And it means that whatever you tell, Google will start to believe it. They will assume that you are telling the truth since you are already the authority. Even if you give the wrong information, since you are the authority for the truth, you will be actually determining what Google will think, what Google will rank. And this is one of the actual purposes of the topical authority. And when you look at the groundedness, the concept of the groundedness, here it is actually touching these uncertain inference at the same time and passage indexing again at the same time. Because one of the answers might be highly accurate for that specific query, and when you look at the groundedness, it might be true for that question, but at the same time, the answer has to be more informative. In other words, we will need to give more unique information. And information extraction requires a strong brain, a careful brain. For example, let's write a simple sentence here, a really simple sentence. Let's say Zeta Jones, Zeta Jones acted in, I am just giving a random sample here, X movie with, let's say, P person. And in 2019, actually, she is nominated for C, let's say, awards. And she is from, let's say, Britain. So when you look at here, if you want to understand information extraction, when you write a sentence, you will need to start generating questions in your mind to understand which questions actually you have answered. For example, let's say, does Zeta Jones acted in X movie? Let's say, does Zeta Jones know P? As you know, the P here is another variable that we can replace with something else. I don't know Zeta Jones that much, so I am using variables like X, Y, Z. And let's say here, let's say, does Zeta Jones, let's say, relate to C awards? And let's say, when is Zeta Jones nominated for, let's say, C words, is Zeta Jones from Britain, or where is Zeta Jones exactly? We can also say that is Zeta Jones an actress, and we can tell that does Zeta Jones have any major, let's say, movies, and let's say at the same time, does Zeta Jones have a role in, let's say, X movie? And we can also ask maybe some other questions here too. But these, for example, these are the questions that you have definitely answered. But at the same time, you can actually use some uncertain inference to understand the most related things. Like, for instance, how many minutes did Zeta Jones play in X movie? How many scenes, let's say, did Zeta Jones play in X movie? And at the same time, we can ask what are the critics for Zeta Jones in, let's say, X movie, and what was the role of Zeta Jones in the X movie. So when you say actually Zeta Jones acted in X movie, so this is the declaration, but when you look at the search engines, they always use the fuzzy logic. Let me explain quickly for information extraction purposes. Does anyone know what fuzzy logic means? I am open to the wrong answers. Answer already actually right here too. Come on, you can do it. We all have logic. No one? No one courageous enough?
Now we just read it, so
Okay, so I will try to give the fuzzy logic a little. Let's say 5 is bigger than 1, then I am telling you that 6 is bigger than 1. So when you look at to the fuzzy logic, or let's say in traditional logic, this is true, and this is true too. But in fuzzy logic, it is different. In fuzzy logic, this is true, let's say 1%. But when you compare the truth level of 5 is bigger than 1 to the 6 is bigger than 1, this one is actually more, even more true than the another one, like 101%, because 6 is actually even more bigger than 1. So when you actually increase the intensity or magnitude of this specific adjective for this specific noun, you are increasing the value of the truth at the same time. So based on that, when you say actually Zeta Jones is British, from a Google's point of view, it's not true or it's not false at the same time. These are for traditional logic. Search engines think like this. With, let's say, 0.70, let's say, or 67% or something like that, it is true. There is no absolute truth in the mind of the search engine. They always use certain types of percentages. And if something is true with 67%, when you say that actually Zeta Jones, let's say Zeta Jones is, let's say, Irish. Now this is not true, this is not false. Most probably it is again true with, let's say, 0.5 is too big, sorry. Let's say 20 or 2% in this case. This means actually 20%. So when you look at the situation like this, there are multiple truths at the same time. And whichever you actually use, the search engine will try to understand the possible distribution of the facts. And at the same time, the word Irish and the word British, they are too close to each other, and sometimes people actually use the word English instead of word British. And when I look at the situation like that, actually maybe it is a little complicated, but Northern Ireland, they are also British, but they are also Irish too. So I know that Zeta Jones is not related to the being an Irish, but when you look at from the search engine point of view, this sentence here is wrong and is true at the same time on certain levels or different levels. And that's why actually we always try to find the most accurate answers, and we try to increase these accuracy scores all the time. And when you look at actually some Other sections here, when you say United States, for example, or other things here, these probability and accuracy, they are connected to each other. So basically, something might be probable or more probable, let's say, but it doesn't mean that actually it is completely accurate at the same time. Sometimes a search engine might actually prefer ranking a certain government website if the situation is under a crisis. During the COVID, we have experienced that, and we even found a new concept which is called search engine promotion. Because search engine literally promoted the official governmental health websites rather than different websites. We have seen many news websites collapse just because they are against the vaccines, or just because actually they are giving the wrong information about the COVID cases or COVID originality or COVID related things. And when you look at the distribution of triples based on URLs, they will always try to understand which one is more probable, more accurate, and with what possibility. And then they will start to aggregate all of this information. And based on this, if you tell Zeta Jones acted in X movie, expand the predicate act. How many minutes, how many scenes, for instance, and how many of these scenes was actually with the P person, and how many of them wasn't with the P person. And when you look at the situation in this way, was the Zeta Jones the actress that actually has most minutes or the more scenes than others? You can actually expand all these things, and whenever you expand, you will be actually giving new declarations, new relations, associations, and at the same time you will be able to give more triples. And whenever it is accurate, it means that you are more reliable. And this is actually how we can expand information content, and this is how actually we can create a bigger information graph, as the samples show here too. So as you know, I call my content designs as semantic content networks, because semantic SEO is basically actually creating neural networks. In a neural network, every neuron is connected to another neuron, and every neuron includes or entails a certain type of information at the same time. That's why search engine also likes these new deep learning algorithms that much. So let's move on to the types of definition, and then we can start to add this, at least this one. And when you look at here, the definition type represents the sentence structure and the style of information given. And uncertain inference of queries might require different definition types. So I will skip this part because I have already explained them a little in terms of this X is bigger than another section, etc. There are other types of logical fallacies too. For instance, 1,000 apples are not too much. If 1,000 apples are not too much, 1,001 apples are not too much too. So you can continue like this until 1 trillion. Because if 1 trillion apples are not too much, it means that 1,000,001 apples are not too much too. And it means that fuzzy logic, in other words, fuzzy logic has to have some borders. And we call these things as the truth ranges. So basically, you can't assume that every declaration will definitely have certain amount of truthness inside of it. If you are exceeding the threshold, if you are very much beyond groundedness, it means that actually you won't have any kinds of possible truth value there, and you are out of the truth range. And when you look at the types of the definition, we have 4 types. Maybe I will try to be quick. So one definition type is object to object. When you say penguin is a bird, you are actually giving a definition. And basically we have 2 objects here. One is penguin, the other one is bird. Concept to concept, it means the rare bird breeds involve red eagles. When you say rare bird, bird is the object, but the rare is the concept. And when you say red eagles, the word red here is one of the other concepts. That's why it is a concept to concept definition. When you look at the object to concept, penguins are funny types of birds. Penguin object and funny types of birds are actually object to concept, because funny types or funny is the concept there. There is also concept to object, like funny types of birds involve penguins too. So when you look at like this, when you look at the situation like this, which definition type do you think that is better than another?
Maybe object to object.
Object to object actually is easier to understand for the search engine, but if you are able to include certain types of concepts along with the objects, actually it is very much more richer, like concept to concept. Most of the time, if you need to define something first of all, use object to object. But for your expansion or expanding for expanding that definition further, you will need to use actually these type of further concepts like gray birds or red eagles as here. And the examples below are just representations of the definitions above, like X is Y, X is a kind of cool Y, X is to provide Y, X is from Y, X has Y. So I won't dive into the set theory and sentence structures because I believe tomorrow I will need to explain the definitions very much more. But I have written this definition by myself and I have actually marked or bolded every attribute. Penguins are flightless, marine birds with flippers instead of wings. Penguins are included in aquatic seabird class. Penguins look similar to the seagulls as torpedo-shaped. And when you look at the penguin definition here, I use a plural answer here rather than a singular thing because this is a breed. If you talk about the breeds, usually you should actually use the plural version. I say flightless and I put it to the first order. And when it comes to the groundedness, informativeness, and relevance, if I start to change order of these attributes, the relevance will start to actually change. Accuracy, magnitude, and everything will start to change. That's why you should put the most popular and important attribute just under your definition. Just directly give it the first thing that you tell for defining a concept, a tool, or any existing thing. It should be the most important thing about the penguins. And usually we understand these most important things by reading the topic or by checking the queries, because most of the time the most important thing will be searched way much more. And when you look at the marine birds with flippers instead of wings, the word flipper here actually, it explains their biology and it is connected to their torpedo shape. At the same time, I repeat the same thing by saying aquatic and the seabird. The word aquatic and marine, they are already semantically relevant to each other and even they are contextual synonyms for certain topics. And when you look at the word seabird, again, it is a repetitiveness or repetition of the marine and aquatic. And when you look at the yesterday lecture, you see that strength-based ranking. We repeat the same thing with different concepts to improve our vocabulary. Because if you have a richer vocabulary, it means that actually your document is richer and you are an expert for the topic. They always compare document vocabularies. If you use more unique and related words for explaining that topic, most probably you will have more relevance for that. So there is another one here. Eagles are members of, I can't read that, bird family with bold golden harpy eagles representing species. They have big beaks with sharp talons, they feed with blah blah blah, they live at blah blah blah, and eagles population on earth, blah blah blah, then I say eagles are icons. So I didn't start by saying eagles are icons to my sentence, because becoming or being an icon is a side attribute, a lesser known attribute, a less important attribute to define the eagles. First I should explain the animal, then I can explain why it is an icon. So you will need to actually prioritize different size or profiles of concepts and entities while defining them as much as possible. And tomorrow we will check these two definitions, especially this one from Google Search, to understand that Google already knows most of the things, like 80% of the things maybe. And to be honest, there is not that much possibility that you can tell something untold about the topic to Google. Most probably Google already knows that. As you remember, we have even tried to find some documents that are relevant to the VPN and SOUP, VPN and water at the same time. We were able to find them even. There are billions and trillions of documents, and in one statistic it was saying 180 trillion web pages exist. And Google already crawls most of them. It means that they have tremendous amount of text, and most probably they have every kinds of word sequence combination that is possible mathematically. So whatever you tell, it will be highly similar to something else. But the thing that you can do is creating a better sentence structure and a better fact order to create a better relevance, to create a better actual responsiveness at the same time. So I believe I have talked a lot again. Now I can answer your questions if you have.
Is the statement true? Entities are a subset of information content.
We can actually tell in that way too. We can assume that entities are centroids or corners of the information, because when you look at the information graph, these nodes are the entities, but the edges, they actually include the predicates, like is a friend of, likes, or is in, is about, painted. These predicates include themes, and the nodes are the entities. So basically entities are actually in a way cornerstones, or in a way they are centroids in the graph, and we actually associate them to each other with certain types of sentences or predicates or relations or relation declarations. Was it clear?
A bit more clear.
I hope so. Any other further question? I will be happy to answer.
I have a question related kind of to the example with the penguins you gave. Obviously, the example was simplified with something we're all aware, so we can understand. However, I have a question in relation to keyword stuffing versus richer vocabulary.
Mm-hmm.
So, for example, you choose to write there penguins are A, penguins are B, penguins are X, Y, Z, versus penguins are A, they are known to be blah, 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 etc., like using different words other than repeating the keyword penguin over and over and over. Do you feel like that has big importance? Like, obviously, we need to use the keyword a lot, but to which point does it become useless to just keep repeating the same keyword over and over in place of using richer vocabulary in these sentences?
Yes, this is one of the patents actually from the Google. It is an old patent actually. By saying old, I mean 10 years, but in patent culture, 10 years is not that much big, or it doesn't that old, to be honest. And I can tell it actually, the status is active, and they actually have refreshed the patent regularly. It is a worldwide application. And this patent or this method or this invention is actually find gibberish content. When we look at the keyword stuffing, most of the time, the keyword stuffed sentences, they actually say the same thing, or they don't say something at all. They just repeat the words without giving any kinds of information. But when you look at this one here, like penguins are, etc., penguins are included, etc., penguins look, etc. When you look at the here, every time in every sentence we actually use different types of words. And since the words in these sentences or between these sentences, since they are different, since they are relevant, plus since they are accurate, and since the grammar structure of the sentences are correct, it won't be a problem. As long as you are giving information with the right grammar structure, and as long as you don't say the same thing 2 times, as long as you are telling the different things with different words about the same entity, still you are actually in the safe zone. And this identifying the gibberish content in the resources. It is actually for finding these type of discordant terms, or these sentences that do not give any kinds of information, and sentences that actually repeat the same thing overall and overall again. And the sentences here, they don't do it actually. They're grammatically accurate, they are giving information, and information itself also accurate, and the words between the sentences, they are not repeating, they are different. So that's why you will be in the safe zone.
To add on to that then, In the example you provided, you're saying that we are in the safe zone to avoid being considered gibberish or keyword stuffing for no reason.
Yes.
Then on the other hand, if we chose to use, for example, penguins are flightless marine birds with flippers instead of wings, they're included. So instead of penguins, we use they are included in the aquatic class. So the facts are still the same, but you replace the keyword penguin with something else. Would we suffer then for not putting the keyword instead? What I mean there is like, if someone wrote a very similar text and they wrote penguins, penguins, penguins at the beginning of every exact correct factual information versus penguins, they, etc., etc.
You can use pronouns too, it's not a problem, but usually I try to use the name of the entity, especially for the beginning section of the sentences. But another thing is, if you want to use a pronoun, you might actually create a co-reference error. And in the co-reference error, it is another concept from the natural language processing. Basically, if you have another animal or another concept or entity around the penguins, the word pronoun might not be associated with the penguin. It might be associated with something else. So that's why at least a couple of times use that specific main entity. Then you, for example, for the fourth sentence, you can actually tell they. Or you can, if you have a synonym for the penguins, you can also use it. Sometimes you can also use a singular one if you want to just change that section. From reader point of view, telling the they might be actually a little richer and better. But from keyword stuffing point of view, as you will be in safe zone, if you want to use the pronoun, be sure that that pronoun has been encapsulated by the entity that you mean. Like here.
That makes a lot of sense. Thank you.
You're welcome. Especially, by the way, for humans, when you say he or she, be sure that you don't have two different males around that he. As I say in fuzzy logic, even if they are sure about it, still they might not be sure that much. As you see from this demo from TextRaiser 2, as I showed yesterday, most probably, you won't see the 100%. It will always be like this. It will always, the confidence won't be 100%. It will, most of the time, you will see percentages with different possibilities all the time, because they are not that sure anytime. That's why we call it fuzzy logic. That's why we call search engine also probabilistic search engine. They calculate probabilities with uncertain inference, then they distribute the best possible combination of possibilities so they can understand and satisfy more people. Okay, any further questions?
In the beginning, you gave that example with love and its relevancy, like relevancy subtopics. Yeah, and you showed the percentage and said that yeah, love as a nickname has 1% of relevance, and let's say movies has 25. And you gave an example, yeah, to use both of them to love nicknames in movies. Mm-hmm. But I'm just thinking, is that a really good idea? From the semantic SEO point of view, theoretically, yes, that might be logical because you sum up two different subtopics, but it's quite a narrow segment when you use them both, and it might be relevant just to very low percentage of users.
Yeah, at the same time you are right, but if you have this topic, for instance, let's say your website is just about nicknames for different situations, let's say for different topics, for different audiences, and let's say someone needs a nickname that is related to the love, and you might actually assume that if someone needs that, they will actually search for the love nicknames or love-related nicknames or nicknames from love novels, movies, etc. They might search for it. If they search for it, you are again in the safe zone. But there will always be a certain types of possibility or percentage that searches for the love, that search love for finding some nicknames. And if you want to also be able to rank for this possible query, you will need to also cover these contexts, or you will need to unite these contexts as VPN and water, for instance. And let's say this is not one of your priorities. In this case, you can also tell that love nicknames from movies, love nicknames from songs or history. You can give all of them under the concept of nickname for different sections, and the topic might be again the love nicknames. But if you want to rank also the query love, just query love, then you will need to also include it in your title too. If you don't want to rank for there, it's okay, then you can continue normally. But again, you most probably you will be missing this 1%, but search engine they won't like missing this 1%, because it means that 1% of the time people that search for the love, they won't find any kinds of related document, and it will be a problem for the search engine, and they will need to solve it by seeking for this type of documents.
Okay.
Okay, then I hope it helps. Any further question? Other silent majority, what are you doing there? And
One question maybe about scoring. You mentioned knowledge base truth and triples. Is there any APIs or tools which could be used to get additional scoring?
certain types of tools, I guess you asked, right?
Yes.
There are a couple of things, but not for the triples. You will need to use your own NLP APIs. I was actually creating something like that. Maybe I can find, but let me just check. NLP, maybe I can find. I'm not sure. No. Let me check my repository a little if I can find. So I was actually curating a couple of things, maybe like this. Maybe I can find this. For example, when you look at here, I performed a search. Then here I actually check results, and I check what adjectives they use, what nouns they use. Nouns here actually are entities already. Most of the time nouns are entities, but it doesn't have to be a named entity. A named entity is an entity like a country, a place, a movie, a song. It has a specific name. But also the word song is also an entity plus an entity type. And when you find any kinds of noun, such as vacation here, such as package, it means that actually people are using this type of content or this type of words there. And I can also understand statistical distribution of the word types or the word roles. Then I lemmatize these things, and this was for Iceland tours. And Iceland, the word Iceland has been used 19 times as an adjective, 8 times as a verb. You might ask me how it can be possible. It's possible if you change the word as Icelandic or Icelandically, I don't know. And these are lemmatized already. In other words, I am using the root of the word, but it means that there are different suffixes that we are also using. And there are contents here and some other things. For example, these are the entity types. For example, there is no work of art. There is not that much language names in the documents, but we have different types of places like Reykjavik, for instance, Great Britain, maybe West Approx, Greenland, Scotland, Norway, Icelandic again is here. So I can check. I didn't continue to create these things because I am managing a company and I hate it, and it doesn't let me to actually focus on these type of innovative things. But on the open market, there is not that much technology for now to check these things. If I complete and publish that Colab, that Code Jupyter Lab, one day, I hope, notebook, I might share it with you as well.
Cool, thanks. Here stuff.
Thank you. So the silent majority. If you also ask a couple of things, I will be happy. So I will read your names as much as I can read. If I butcher your name, forgive me. Nozomi Nishimura. You can also ask a couple of questions if you want.
Yes. So my question is, you're talking about accuracy, right?
Yes.
Triple. So how can Google judge if it's accurate or not?
So from Google's point of view, as I say in the fuzzy logic section, there is not absolute truth or there is no absolute wrong. They just calculate the possible probabilities, And to be able to do that, they will need to actually find and accept some central seed sources for certain topics. And maybe yesterday I actually showed it from the corroboration answers from Open Web section. This is another research. And I actually have shown this example. If you search for Honda Civic 2007 gas mileage, you will realize that every web page actually gives a different answer. And since this is external world, as a machine, you don't have that much power to understand the external world. It means that you will actually need to accept one really good authoritative source. And for when it comes to Honda Civic, you can accept that Honda is the authority. And even the Honda gives two different answers. It means that you will need to give an average and a range. And you will accept that any answer that is in this range will have actually a higher accuracy. Any answer that is out of this range, it will be different. There is one more methodology. I have actually written it in my book. Maybe I have shown it before. I didn't publish this book. I have written it like 10 months ago, but I still wait Rebecca Berbel to revise it because I use highly robotic language. And I don't like, actually I like what people don't like. So I need Rebecca to revise it. And here too, I have explained how the feature snippets are chosen, evaluated, scored, etc. And one of the things there is, if the first answer is the main truth, they will need to take the most similar ones to this one. But at the same time, if we have a new document at the order or rank here, let's say, and if its answer is different, it also affects overall truth range or average value for the truth. In this case, the other answers from second page, other answers from third page, they will also need to be re-evaluated. So in other words, it is a continuous process of crawling, continuous process of extracting information, aggregating the information, and also scoring the resources according to their overall authority. And usually if you are an authoritative source for the topic, most probably other sources will rank if their declarations are similar to yours. If they are not similar, they won't rank that much. Like this. Thank you for asking the question.
Yeah, thank you so much.
You're welcome. We have some other people here too, but I believe we have spent like 70 minutes here, and I know that you are already bored. So tomorrow I will repeat a couple of sections for the definitions, then I will continue from the sentence structures and set theory, and then actually we have a little inheritance and then attributes a little. So it will be fun and okay. I will be uploading this recording to the recording sections that is replaced in this area, and there will be a third one here. You can watch it whenever you want, and thank you for everything. See you tomorrow.
Thanks.
Thank you.
Thank you.
Thanks.